One, two. One, two. One, two. One, two. One, two. 1, 2, 3, 4. 1, 2, 3, 4. VK3 CSJ testing. Hello, 1, 2. One, two, three, four. One, two, three, four. 1, 2. Good evening. This is VK3CSJ. Sorry, VK3EKH, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast. Coming to you from the studios of VK3CSJ, CSJ, in Narre Warren South. Broadcasting on prime frequency 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3RTV digital channel 1, and just making sure my audio levels there are okay. Should be okay. 1, 2. We're also streaming to Discord, and both HD video, and also via my YouTube channel. And I can tell it's working because I'm using the mobile telephone connection, which seems to survive the onslaught of RF. Although I can, because of the reduced bandwidth, I can see my stream flicking away there, telling me there's not quite enough, but apparently it should be working okay from past experiments. So, good morning, good evening to everybody on this eve of the Olympic Games in Paris, the opening, the celebration thingy starts at just on 3 o'clock in the morning. Not that I could be up still by then, but don't think I'll get quite sucked into watching it. But it's all happening, and looking forward to how things progress over the next couple of weeks. Anyway, I'm not sure there's enough audio level there on HF. Where am I here? 1, 2, 1, 2. Hopefully that'll be okay. 1, 2, 3, 4, 5. 5. Yeah, it should be right. 1, 2, 3, 4, 5. All right. Good evening, everybody. On the 26th of June, it's nearly July. It's nearly the end of the month. How quick time is flying. We've got a band of rain coming across, stretching from Adelaide right down to King Island, Tasmania, and looks like our weekend is going to be a damp one. I've got the radar running here too, so I can quickly show that. Actually, there it is for those watching the video side of things. There is the current radar map of it's looking like over Western Victoria aspect along the coastline at least. So yeah, things aren't too good. Another wet weekend, in other words. Okay, we also have an email address, vk3ekh@gmail.com, vk3ekh@gmail.com, and also, well, like I say, the chat room on Discord. Discord is up and running, and I already can see there's a bunch of stations watching the HD stream. Okay, guys, so for those that are listening in real time, on 80 meters at the same time, the vision is only less than a second, or around about that, compared to YouTube. So that's the key thing about Discord. So g'day to Luke, Richard, Steve and Stuart that are watching. And as far as the chat room is concerned, have a quick look at the chat room, and I can see Stuart's there. Good evening all. And Mr. SPX, everything's working, he says. Good, so I'm glad to hear that. Okay. We've got a few interesting articles tonight, all scrounged off the internet very quickly in the last hour, as the way things go. No space weather report from Tamitha, however. Nothing coming in from her at this stage, so we'll just do it with the usual spaceweather.com stuff, and see how we go with that. Alright, just the usual blurb. The Astronomical Society of Victoria was founded in 1922. It comprises well over 1,600 members throughout the states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. Meetings start at 8 o'clock in the Mullier Hall, the National Herbarium, in Burwood Avenue, Melbourne, near the Melbourne Observatory. Parking is available in Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free and visitors are most welcome. There's usually a little bit of a supper after, a free cup of tea and coffee with bickies. But the general aim is to have the meeting finished by 10 o'clock, and as such. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook, which is published by the ASV once a year, hence the reason why it's called a yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and at the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor, which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory. The Society has a number of 200mm reflectors available for short period loan in the in the loan scheme, the telephone loan scheme that ASV have got running. Regular Society Club night meetings are held at the Melbourne Observatory in the Ellery Suite at Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of small reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, about a 90-minute drive north of Melbourne, 2.5 hours if you're out where I am. There are a range of instruments available for members to use, the larger tube with appropriate training. And they range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5 metre 30-foot radio telescope, which members can get involved with if you become to join the radio astronomy section. Pleasant good evening to any RAS members that happen to be listening. I don't get much feedback from RAS members that might watch this. I think they're usually hitting the sack. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, the computing section, cosmology and astrophysics. Historical studies, research and astronomy in general, all catered for one way or another. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website at www.asv.org.au, and all will be revealed. Via email, there is something the ASV is now doing, or has been doing for quite a while now actually. It's called the Crux Extra Bulletins, and it is an email publication to members only, and that gets sent out at random times to keep members informed of what's happening, or events that are coming up in the following weeks and stuff like that. Please note that ASV will conform to all government health directives. Of course, the ASV events may be required to be cancelled, moved or postponed. If you wish to send a letter as such to the ASV, address it to the Secretary of the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. The almanac, the Astronomical Yearbook, I should say, it's kind of an almanac, is a lovely little publication. It's what I read from every day, every Friday. All that dialogue that I read is on the inside cover, as you can see just there for those watching visions. And but it's a beautiful publication. It's a very extensive little book that ASV does, and it's just, if you're into doing astronomy, this is just the sort of thing that you would need for being able to confirm what's happening above our heads. Otherwise, go to heavensabove.com. Having said that, as mentioned last week, and I'll give this for a few weeks a plug on this, ASV have now released a new magazine of such. It's called The Southern Astronomer. The Southern Astronomer. The first edition of The Southern Astronomer has arrived. It's a quarterly magazine, and it's your ultimate cosmic companion, packed with news on science, astronomy and astrophotography and space exploration. We shine a spotlight on the southern hemisphere and a region brimming with extraordinary people who have made amazing contributions to the world of astronomy and science. And I can just quickly bring up the look of that little magazine, which is this guy. There it is for those watching ATV. I'm getting a good signal off RTV tonight too, incidentally. That's the front cover, and on the inside, if I can just find that quickly enough, is this? No, it's not that one. Okay. Oh yeah, all right. So if I bring that across, I should be able to cursor that down. Alright, so yeah, so that's the contents of the magazine as it is, this first edition, what they refer to as the winter edition, and boy isn't it winter. So yes, you've got letters to the editor, although that could be just starting, but there might be a letter or two. Or maybe actually it's editor's letter. Alright, so it's a note from the editor, okay. And anyway, you can see the various contents there. It's quite a few things, full of interesting stuff to read. Meet Rover, the Great Auroral Storm, something there to do with our Aboriginal beginnings, star stuff, dark matter down under, bright comets for 2024, the southern sky at night, the lucky hemisphere, ripples in space-time, what are cometary globulars, how to observe a comet, product review, which is the new C-Star telescope device, and keep staring into space. Anyway, that's just a quick view of this new online magazine. Of course, you have to subscribe to it to be able to get the full benefit of it. I'm just quickly skimming through it there on the video side of things, so you can get a bit of an idea of what it looks like. So yeah, there it is, and the website is www.southernastronomer.com. www.southernastronomer, all one word, southernastronomer.com, and explore the homepage and see whether it is of any value to you. So that's a nice little addition to what the ASV are trying to do at the moment in keeping everybody abreast of what's happening above our heads. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, been transmitting since 1988. More information about the station here can be found on the QRZ.com page. Just type in VK3EKH on the QRZ.com page. We're broadcasting via the Melbourne television repeater, VK3RTV, Digital Channel 1, and also via Discord HD. There's a HD video stream on our Discord, so if you're not if you don't have Discord, just type in Discord in the favourite search engine and type in Discord and register. There's no money involved. It's a free registration thingy. There's a few questions that have to be asked, but once you've established an account as such with Discord, just type in or search for Astronomy Chat Room, and that hopefully should link you into where we are, and then click around. You'll eventually find the video stream. I can provide a link that gets you to the video stream a little bit more precisely. Right, now, first article for tonight. Let's see. We have. Oh yes, I've done that already. Okay, courtesy of astronomy.com. And the image they've got for this article is trying to find it here amongst everything else. Yeah, no, I've got it there. I've got it there somewhere. vMix can be such a bother sometimes, and just trying to find that. There it is. It's right in front of me. It's just gone past my eyes several times. There we are. Okay. So this was published July 17, 2024. And title of the article is "What Would Happen if a teaspoonful of neutron star was brought to Earth?" And that's a question that's asked by Carolyn Adams of Portland, Oregon. And the reply to that is, before we can know what happens when a spoonful comes to Earth, let's think about what's in our spoon: a super dense collection of neutrons. A neutron star is the remnant of a massive star, bigger than 10 suns, that has run out of fuel, collapsed, exploded, and collapsed even some more. Its protons and electrons have fused together to create neutrons under the pressure of the collapse. The only thing keeping the neutrons from collapsing further is the pressure associated with that collapse, which prevents two neutrons from being in the same place at the same time. Additionally, the star loses a lot of mass in the process and winds up only about 1.5 times the mass of our Sun, or the Sun's mass. But all that matter has been compressed to an object about 10 miles across, or 16 kilometers across. A normal star of that mass would be more than 1 million miles, or 1.6 million kilometers across. Therefore, a tablespoon of the Sun, depending on where you scoop, would weigh about 5 pounds, 2 kilograms. The weight of an old laptop. A tablespoon of neutron star weighs more than 1 billion tons, or 900 billion kilograms, the weight of Mount Everest. So while you could lift a spoonful of Sun, you can't lift a spoonful of neutron star. Such imagination. And the image on the screen right now, incidentally, is it says here that neutron stars are incredibly dense objects, about 16 kilometers across. Only their immense gravity keeps the matter inside from exploding. If you brought a spoonful of neutron star to Earth, the lack of gravity would cause it to expand rapidly, is what they're saying in that regards to that image there. So continuing on. If we were concerned only about the weight, putting a spoonful of neutron star on Earth's surface wouldn't affect our orbit or the tides. It's like adding another mountain. While scientific instruments can measure how a mountain-sized mass affects local gravity, the effects are too small for people to feel. So unless you stood right next to the spoon, you wouldn't notice. However, we're not just worried about the mass in the spoon. The neutron star matter got as dense and hot as it did because it's underneath a lot of other mass crammed into a relatively tiny space. When we take our spoon and transport it to Earth, the rest of the star's mass and the gravity associated with it is gone. Inside a neutron star, the neutron pressure is fighting gravity, but without all that gravity, the pressure takes over. Imagine you have a can of soda and it's all shaken up. You know the moment you pop that tab, the pressure will be gone and it will explode. When we bring our spoonful of neutron star to Earth, we've popped the tap on the gravity holding it together, and what's inside expands very rapidly. A spoonful of neutron star suddenly appearing on Earth's surface would cause a giant explosion, and it would probably vaporize a good chunk of our planet with it. So there it is. Let's not go picking up spoonfuls of neutron star, okay? This is VK3EKH, the official station of the Astronomical Society of Victoria. Time is 10:23. Okay, let's get to something else that's more practical. An underground cave discovered on the moon could shelter future lunar astronauts, courtesy of Science Alert, published 18th of July. I was going to run this last week, but didn't, ran out of time. There's an image here, which I can bring up, of this cave thing. Okay. It's really not going to be easy for humans to set up a habitat on the moon, but new discovery could alleviate some problems. An analysis of radar data suggests a gaping hole in the lunar crust could lead to a network of caves which future lunar explorers might use for shelter. We've known about the holes called skylights in the surface of the moon for some time now. We finally have evidence that they exist. These caves have been theorized for over 50 years, but it is the first time ever that we have demonstrated their existence, says astronomer Lorenzo Bazzone of the University of Trento in Italy. The environment on the moon is very different to the one we evolved in, as on Earth. So it isn't very kind of human psychology. There's no atmosphere to breathe, for one, and there are the temperatures. A day on the moon lasts around 14 days, as does its night. During the day, temperatures can reach as high as 121 degrees Celsius, 250 degrees Fahrenheit, but then plunge down to minus 133 degrees Celsius after sunset. Not to mention the solar and cosmic radiation. Earth's atmosphere protects us from the worst of it. The moon constitutes a radiation environment that would be considered hazardous to human health. Cue lava tubes. And there's another image here associated with this article. This one here. Okay, Q lava tubes. These are created when lava solidifies as the surface while continuing to flow underneath. Eventually, the underground current of lava drains away, leaving a hollow cavity under a now solid volcanic rock layer or a natural cave. They can happen anywhere there has been volcanic activity. We have them here on Earth. They've been spotted on Mars, and whole networks are thought to exist on the moon. These lunar lava tubes are of keen interest to scientists designing lunar exploration missions, since they could provide a human moon-based protection from the harsh surface environment. But positively identifying a cave system just from holes on the lunar surface has been a bit of a challenge. And this image on the screen right now is a simulation of the cave extending down from that particular sunken hole that I showed previously. Now, led by astronomer Leonardo Carrà of the University of Toronto, a team of researchers says that they have finally made such an identification. The observations come in from the form of radar data collected in 2010 by NASA's Lunar Reconnaissance Orbiter. As it flew over an ancient lunar basalt plain called the Sea of Tranquility, it spotted a hole in the surface of the moon, a skylight that appears when part of the lava tubes cave in. Years later, we have reanalyzed these data with complex signal processing techniques. We have recently developed and have discovered radar reflections from the area of the pit that are best explained by an underground cave conduit. This discovery provides the first direct evidence of an accessible lava tube under the surface of the moon. The next step was to model the shape of the tunnel beneath the skylight. The best explanation for the structure the researchers found was a lava tube extending from the skylight into the interior of the moon. Now we can just put down any old Now we can't just put down any old where on the moon. The landing site, particularly for a crewed mission, needs to be carefully considered. We've already sent humans to the Sea of Tranquility, so it's unlikely to be top of the list for the next mission, especially since the polar regions have exciting features to be checked out, such as craters where possible water ice is found. But having found one lava tube on the moon means that there are likely to be more up there that are waiting to be discovered, and identifying where they are could help narrow down the best sites for long-term lunar base. This research, says planetary geologist Wes Patterson of Johns Hopkins University, demonstrates both how radar data of the moon can be used in novel ways to address fundamental questions of science and exploration, and how crucial it is to continue collecting remotely sensed data of the moon. So there it is. Okay, just find my camera. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Oh, there's actually, I should play my little official announcement, shouldn't I? Where is that? It should be just in there. One of these ones. Yes, here, I think. Let's see what happens when I do this.
You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South.
Right, thanks Rolf for that. I'm not sure if that went everywhere. I know it went over HF, and I think it went over ATV. But I'm not sure if it actually went over Discord, but I think it might have. Anyway, thanks Ralph for that professional speaking voice. 10:31. Next article. Let me see. We're now across to this one. Okay, this is fairly current. July 25, published July 25 on NASA website, and this is called How NASA's Roman Space Telescope Will Illuminate Cosmic Dawn. So yet another space telescope is being planned, and there's an interesting artist's concept here which I'll bring up while I start off with this article. And when I first saw this, I thought this is really a stunning image, but it's just an artist's impression, so don't get too carried away by what you're about to see. But as the article continues, in fact, this artist's impression, you see, this artist's concept shows how the universe might have looked when it was less than 1 billion years old, about 7% of its current age. Star formation voraciously consumed primordial hydrogen, churning out a myriad of stars at an unprecedented rate. NASA's Nancy Grace Roman Space Telescope, will peer back to the universe's early stages to understand how it transitioned from being opaque to the brilliant starscape we see today. And the article continues on to say that today, enormous stretches of space are crystal clear, but that hasn't or wasn't always the case. During its infancy, the universe was filled with a fog that made it opaque, cloaking the first stars and galaxies. NASA's upcoming Nancy Grace Roman Space Telescope, NGRST, will probe the universe's subsequent transition to the brilliant starscape we see today. It's an era known as the cosmic dawn. Something very fundamental about the nature of the universe changed during this time, said Michelle Thorler, an astrophysicist at NASA's Goddard Space Flight Center in Greenbelt. Thanks to Roman's large, sharp infrared view, we may finally figure out what happened during a critical cosmic turning point, she says. Shortly after its birth, the cosmos was a blistering sea of particles and radiation. As the universe expanded and cooled, positively charged protons were able to capture the negatively charged electrons to form neutron atoms, mostly hydrogen, plus some helium. That was great news for the stars and galaxies the atoms would ultimately become, but bad news for light. It likely took a long time for the gaseous hydrogen and helium to coalesce into stars, which then gravitated together to form the first galaxies. But even when stars began to shine, their light couldn't travel very far before striking and being absorbed by neutral atoms. This period, known as the Cosmic Dark Ages, lasted from around 380,000 to 200 million years after the Big Bang. Then the fog slowly lifted as more and more neutron atoms broke apart over the next several 100 million years, a period called the Cosmic Dawn. We're very curious about how the processes happened, said Argon Young, a Grassoni Fellow at the Space Telescope Science Institute at Baltimore, who is helping plan Roman's early universe observations. Roman's large, crisp view of deep space will help us weigh different explanations, he said. It could be that early galaxies may be largely to blame for the energetic light that broke up the neutral atoms. The first black holes may have played a role too. Roman will look far and wide to examine how possible or both possible culprits. Roman will excel at finding the building blocks of cosmic structures like galaxy clusters that later formed. Just reading ahead, it will quickly identify the densest regions where more fog is being cleared, making Roman a key mission to probe early galaxy evolution and the cosmic dawn. The earliest stars were likely starkly different from modern ones. Starkly. It's It's a word they invented, I'm sure. The earlier stars were like starkly different from modern ones. When gravity began pulling material together, the universe was very dense. Stars probably grew hundreds of thousands of times more massive than the Sun and emitted lots of high-energy radiation. Gravity huddled up the young stars to form galaxies, and their cumulative blasting may have once began or again stripped electrons and protons in bubbles of space around them. You could call it the party at the beginning of the universe. We've never seen the birth of the very first stars and galaxies, but it must have been spectacular, says one of the scientists. But these heavyweight stars were short-lived. Scientists think they quickly collapsed, leaving behind black holes, objects with such extreme gravity that not even light can escape their clutches. Since the young universe was also smaller, because it hadn't been expanding very long, hordes of these black holes could have merged to form even bigger ones, up to millions or even billion times the Sun's mass. Supermassive black holes may have helped clear the hydrogen fog that permeated the early universe. Hot material swirling around black holes at the bright centers of the active galaxies, called quasars, prior to falling in, can generate extreme temperatures and send off huge, bright jets of intense radiation. The jets can extend for hundreds of thousands of light years, ripping the electrons from any atom in their path. NASA's James Webb Space Telescope is also exploring the cosmic dawn, using its narrower but deeper view to study the early universe. By coupling Webb's observations with Roman's, scientists will generate a much more complete picture of this area. So far, Webb is finding more quasars than anticipated, given the expected rarity and Webb's smaller field of view. Roman's zoomed-out view will help astronomers understand what's going on by seeing how common quasars truly are, likely finding tens of thousands compared to the handful Webb may find. And there's another image here, which this one is real. Okay, there it is. So what you're looking at there is a real image. In this view, this view from the James Webb Space Telescope contains more than 20,000 galaxies. You could almost count them in that image. Researchers analysed 117 galaxies that all existed approximately 900 million years after the Big Bang. They focused on 59 galaxies that lie in front of the quasar J0100 plus 2802, which is an active supermassive black hole that acts like a beacon, located at the centre of the image above, or the image that you're seeing now, appearing tiny and pink with 6 prominent diffraction spikes. Yes, you can see that. Yeah, there's one particular, there's actually several of them. Oh no, it's in the middle. Yeah, it's got a kind of a pinkish colour to it. It's pretty much in the middle of that image they're referring to. Where was I? Located at the centre of the image above, appearing tiny and pink with 6 prominent diffraction spikes. The team studied both the galaxies themselves and the illuminated gas surrounding them, which was lit up by the quasar's bright light. The observation sheds light, pardon the pun, the observation sheds light on how early galaxies, cleared the fog around them, eventually leading to today's clear, expansive views. So to finish off, with a stronger statistical sample, astronomers will be able to test a wide range of theories inspired by Webb's observations. Peering back into the universe's first few 100 million years with Roman's wide-eyed view will also help scientists determine whether a certain type of galaxy, such as more massive ones, played a large role in clearing this fog. It could be that young galaxies kicked off the processes and when quasars just finished the job. Seeing the size of the bubbles carved out of the fog will give scientists a major clue. Galaxies would create huge clusters of bubbles around them, while quasars would create large spherical ones. We need a big field of view like Romans to measure their extent, since in either case they're likely up to millions of light years wide, often larger than Webb's field of view. Romans will work hand in hand with Webb to offer clues about how galaxies formed from the primordial gas that once filled the universe, and how their central supermassive black holes influence galaxy and star formation. The observations will help uncover the cosmic daybreakers that illuminated our universe and ultimately made life on Earth possible. The Nancy Grace Roman Space Telescope is managed by NASA's Goddard Space Flight Center at Greenbelt, with participation of NASA's Jet Propulsion Laboratory and Caltech in Southern California, the Space Telescope Science Institute in Baltimore, and the science team comprising scientists from various research institutions. So that image there has about, let's say, 20,000 galaxies sitting in it. Now, in that one image there would have to be life out there somewhere amongst all that. It's just got to be. All right, you're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcasts coming to you from the studios of VK3 CSJ in Narre Warren South. Okay, this is just going to be a quick article. It goes on for a bit. I don't think I need to read it all out, but essentially the International Astronomical Union wants to tighten up the definition of a planet, what's considered a planet. I think there's a group out there that's very, very keen to give Pluto its old designation as a planet and remove this dwarf thing. I think that's what's going on here. Astronomers propose we change the definition of planet. Here's why. Courtesy of space.com, 20th of July. What is the true definition of a planet, and could there be a more refined definition in the future? This is what a recent study published in the Planetary Science Journal hopes to address as a team of researchers from United States and Canada investigated the potential for a new definition of a planet. This study holds the potential to challenge the long-standing definition outlined by the International Astronomical Union, IAU, which established the IAU Resolution B5 in 2006, resulting in demoting Pluto from a planet to a dwarf planet. Here, Universe Today discusses this incredible research with study lead author Dr. Jean-Luc Margot, who is a professor of the Department of Earth, Planetary and Space Sciences at the University of California in Los Angeles. Regarding motivation behind the study, significant results, what steps need to be taken for the IAU to implement this new definition, and whether Dr. Margot thinks Pluto should be reclassified as a planet. So, behind the study, you may ask. The IAU Resolution B5, Bravo 5, is problematic. It is vague and excludes exoplanets, and the problems will not go away on their own. Our community and the public deserve better definitions for such important astrophysical terms as planet and satellite. We have had 18 years to identify the problems and consider possible ways forward. there are good reasons to believe that we are better equipped in 2024 than in 2006 to produce a good outcome. According to the IAU Resolution B5, the current definition of a planet is as follows. A. Is in orbit around the Sun. B. Has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, i.e. nearly round, shape. And C. Has cleared the neighbourhood around its orbit. Unfortunately, this resulted in Pluto being demoted from a planet to a dwarf planet since it did not meet criteria C. Again, that C is having cleared the neighbourhood around its orbit from debris. Additionally, IAU Resolution B5 limits itself to planets within our solar system, specifically pertaining to planets orbiting a single star. In contrast, approximately 50 exoplanets have been confirmed to orbit one star within a binary two-star system. Therefore, a new IAU definition that encompasses exoplanets could help establish a better framework for planets throughout the cosmos. While IAU Resolution B5 is considered a quantitative non-mathematical definition for planets, this recent study attempted to develop a more quantitative mathematical definition, or planetary taxonomy classification that could encompass planets and satellites, moons, both within and beyond our solar system. To accomplish this, the researchers used a series of equations to calculate a planetary's body ability to clear a zone, which coincides with criteria C of the IAU Resolution B5, with a goal of ascertaining the approximate size and planetary body needs to be to clear a zone. Additionally, equations were also used to ascertain the difference between a planet and a satellite as well. Therefore, what were some of the most significant results from this study? Well, we suggest that planetary bodies can be classified on the basis of properties that are easily measurable, orbital elements and masses. Dr. Margot says, we find that the unsupervised clustering of solar system bodies according to orbital elements and masses yields distinct groups. The clustering reveals that satellites are distinct from planets, and it reveals that 8 planets are distinct from all other bodies. The presence of these groups and the gaps between these groups provides natural dividing lines for planetary taxonomy. So they propose a single clearing timescale applicable to all stars, stellar eminence, and brown dwarfs. We propose a definition that is aligned with IAU's recommendations, but we also examine potential difficulties related to these recommendations. We propose a simpler, mass-based proposal that avoids some of these difficulties. This proposal consists of the following definition. A planet is a celestial body that A. orbits one or more stars, brown dwarfs or stellar remnants, and B. is more massive than 10 to the power of 23 kilogram, and C. is less massive than 13 Jupiter masses, which is 2.5 by 10 to the 28 kilogram. A satellite is a celestial body that orbits a planet. Suffice to say, this article goes on for a little bit longer, and I'll leave it there. But suffice to say, there are definitely some attempts there to try and reclassify what's considered a planet. And because there's been planets discovered around exoplanets, they want to try and push these definitions to encompass the exoplanets as well. I can see there's a reference to radio astronomy in this article too, I can see, but I won't worry about that right now. But if you wish to have a further look on that article, it's on the Science Alert website, www.sciencealert, all one word, sciencealert.com. and look under space for astronomers propose we change the definition of a planet. Here's why. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. There was something else I was going to mention, but I've inadvertently closed the page, so I'm going to leave that till next week. So we're going to go straight into spaceweather.com. How's that? The article that I did have, but like I said, I've inadvertently closed the page, was dealing with five asteroids, near-Earth asteroids that are of some concern to NASA. And I was going to quickly run through those 5 asteroids and the potential for what could be life-threatening scenario if one of them was to hit Earth. Next week. We'll leave that to next week. All right. Spaceweather.com. Currently, the solar wind is at 524.8 kilometres a second. It's just a gale. At a density of 0.13 protons per cubic centimetre. I should demonstrate that little cubic centimetre cube and demonstrate how many protons are in that. Anyway, the sun is currently looking like this. I'll just bring this up. There we are. So if you were able to see the disk of the sun right now with protective glasses, of course, that's roughly how it would look at this present point in time with all those sunspots there. The sunspot number is currently 171, whilst the radio sun is measuring 167 solar flux units recorded at a wavelength of 10.7 centimetres. So 167 solar flux units, and the sunspot number is 171. Going down a bit, we shall take a quick look at the aurora over Antarctica as we speak. There it is. So there's a bit of a glow there. If you were right there south of Tasmania, looking south, you'd probably be able to see a bit of a glow in the southern sky, but it's not very intense. And the KP index. All right, I'm just going to spend a little bit of time on this one because I often read out the KP planetary K index. The KP index currently is 4, considered unsettled, and the 24-hour max KP index is 4.67, which is also considered unsettled. This information is also broadcasted on WWV at certain times of the day to keep people who just love to listen to WWV 24 hours a day abreast of what's happening with our space weather. I'm just going to bring up something here. That'll do. Go across. Oh, come on. Trying to bring an image across and it's not doing it. There we go. All right. Let me see. Now, hang on. Just bear with me. Okay. Now, to give you an idea, briefly explain some of the ideas behind the association of the aurora with geomagnetic activity, and a bit about how the K index or K factor works. The aurora is understood to be caused by the interaction of high energy particles, usually electrons, with neutral atoms in the Earth's upper atmosphere. These high energy particles can excite, by collisions, valence electrons that are found or bound to the neutral atom. The excited electron can then de-excite and return back to its initial lower energy state, but in the process it releases a proton, a light particle. The combined effect of many protons being released from many atoms results in the aurora display that you see. The details of how high energy particles are generated during a geomagnetic storm constitutes an entire discipline of space science in its own right. The basic idea, however, is that the Earth's magnetic field, let us say the geomagnetic field, is responding to a outwardly propagating disturbance from the Sun. As the geomagnetic field adjusts to this disturbance, various components of the Earth's field can change form, releasing magnetic energy and thereby accelerating charged particles to high energies. These particles, being charged, are forced to stream along the geomagnetic field lines. Some end up in the upper part of the Earth's neutral atmosphere and the aurora mechanism begins. The disturbance of the geomagnetic field may also be measured by an instrument called a magnetometer. At our operations center, we receive magnetometer data from dozens of observatories in 1-minute intervals. This data, received at or near to real time, allows us to keep track of the current state of the geomagnetic conditions. In order to reduce the amount of data that customers have to deal with, we convert the magnetometer data into 3 hourly indices, which give a quantitative but less detailed measure of the level of geomagnetic activity. The K-index scale has a range from 0 to 9 and is directly related to the maximum amount of fluctuation relative to a quiet day in the geomagnetic field over a 3-hour interval. The K-index is therefore updated every 3 hours, and the information is made available to our customers as soon as possible. The K-index is also necessarily tied to a specific geomagnetic observatory. For locations where there are no observatories, one can only estimate what the local K-index would be by looking at the data from the nearest observatory. But this would be subject to some errors from time to time because geomagnetic activity is not always spatially homogeneous. Another item of interest is that the location of the aurora usually changes geomagnetic latitude at an intensity of the geomagnetic storm changes. The location of the aurora often takes an oval-like shape and is appropriately called the auroral oval. A useful map of the approximate location of the aurora oval is a function of the KP index. Is a function. I'm reading across the screen here. I keep losing my space. A function of the KP index was published in June 1968 copy of Sky and Telescope. See page 348. The KP index is derived through an algorithm that essentially averages the K indices from several stations. Note that as a storm becomes more intense, the edge of the auroral boundary typically moves to lower latitudes. For further reading, we can recommend a couple of books for you. An old but classic text is The Polar Aurora. The Polar Aurora, Oxford University Press, published 1955. A more modern text is The Physics of Space Plasmas, The Physics of Space Plasmas, 1991, by George Parks. Just checking on that. Yep. So, nevertheless, as you can see in the map on the screen, the KP index is also, as the article was saying just then, is reference to latitudes. KP3 is closer to the North Pole, KP5 is a bit further away, KP7 is a bit further away, KP9 is going through the States, and it would be a similar scenario to the South Pole. So, that's what that all means when we refer to the KP index. So, the planetary K index, KP is currently 4. Unsettled, the 24-hour KP is 4.67, also considered unsettled. If you wish to read that for yourself, just go to spaceweather.com, look for the planetary K index on the left-hand column, and right underneath that is an explanation of all that, which is what I just read out, more or less. And there's some more data that's present as well. Okay. Having said all that, geomagnetic storm watch continued. A CME struck Earth yesterday, July 25th, at 14:22 UT. The impact did not immediately cause a geomagnetic storm, but the watch is not over yet. Minor G1 class storms are possible today as Earth passes through the CME's magnetized wake. Major far-side solar flare, the biggest flare of the solar cycle 25, just exploded on the far side of the sun, and here is a measure of that disturbance. And we also have a did not want to do that. Hang on a sec, go back. And we have a GIF image of this happening. So before I change the picture, the biggest flare of solar cycle 25 just exploded, and X-ray detectors on Europe's solar orbiter space registered an X14 category blast, which is what you see on the screen there, an X14, which is pretty intense. Solar orbiter was over the far side of the sun when the explosion occurred on July 23rd, in perfect position to observe a flare otherwise invisible from the sun. And this is another view. From the estimated GOES class, it was the largest flare so far. An X-rays telescope on SOIO, which can detect solar flares and classify them on the same scale as NOAA GOES satellites. Other large flares we've detected from May 2024, which was an X12, and July 17, 2023, an X10. All these have come from the backside of the sun. Meanwhile, on the Earth side of the sun, the largest flare so far registered was an X8.9 on May 14, 2014. SOIO has detected at least 3 larger far-side explosions, which means our planet has been dodging a lot of bullets. The X4 far-side flare was indeed a major event. It hurled a massive CME into space, shown here in this coronagraph movie from the Solar Heliospheric Observatory, SOHO, S-O-H-O, and you can see it there. The CME sprayed energetic particles all over the solar system. Earth itself was hit by hard protons, despite being on the opposite side of the sun. This is a big one, a 360-degree event, says George Ho of the Southwest Research Institute, principal investigator for one of the energetic particle detectors on board SOIO. It also caused a high dosage at Mars. SOIO was squarely in the crosshairs of the CME, and on July 24th it experienced a direct hit. In a matter of minutes, particle counts jumped almost 1,000-fold as the spacecraft was peppered by a hailstorm energetic ions and electrons. This is something we all call an energetic storm particle ESP event, explains Ho. It's when particles are locally accelerated in the CME's shock front to energies higher than a typical solar radiation storm. An ESP event around Earth in March 1989 caused the Great Quebec Blackout. So that's what might have happened if the CME hit Earth instead of the SOIO maybe next time. The source of this blast will rotate around to face our planet a week to 10 days from now. So I'm sure Tamitha will have a dedicated report on that. So, having said all that, this is the current solar chart. So, for those watching the visions, the top chart is the sunspot number progression, and the bottom chart is the 10.7 wavelength radio flux progression. So we're still, our solar flare activity, or solar climax, solar peak cycle, that's it, what I'm trying to get to, is still reaching its maxima. We've still got quite a few months to go before the solar cycle has reached its maxima. So there is going to be lots and lots of activity. Certainly our daytime and nighttime ionosphere is going to get well and truly energized one way or another. So for all you DX chasers out there, it's going to be a very interesting 12 months to 18 months coming up, if it hasn't already. So I think that's about it for this evening. I'll just go back to my camera. That's that one there. So that camera there's got taking in the output of the TV repeater on my monitor there. So that's there it is. You can see the delay there. All right. As of July 26, 2024, there were 2,349 potentially hazardous asteroids. I don't think that figure's changed very much over the last month or so. On that note, we shall conclude tonight's session for the 26th of July. And what I'll do now is go across to the radio and to the transceiver, more correctly. And let's see if we can pick up any stations wishing to check in for tonight at this time of the night. Just getting my pad and pen ready. Okay, so this is VK3EKH listening on 3541 for any stations wishing to check in.
VK3SPX.
Goodness, I must have gone overtime. It's only 11:11. G'day, Steve. VK3SPX. Is there any other stations wishing to check in?
VK5 Whiskey Alpha.
That's a good signal from you there, Dallas. Any other stations? So VK5MY, was it? VK5 Mike Yankee, was it? Oh, okay, we'll come back to you in a minute. Any other stations wishing to check in? Very quiet. People must have gone to bed early so they can get up and watch the opening ceremony for the Olympics. It's the only way I can think of it. I think the footy match is over. Anyway, you take it, Steve. VK3SPX, VK3EKH.
VK3EKH, VK3SPX. Yeah, that's extraordinary. I paused a bit because normally Graham jumps right in, so I thought I'll just wait a little bit, and I thought, where's Graham? So I thought I'll try and mind you. My call's on now. I did hear someone after 5WA, but he didn't call back again. Maybe we'll hear in a minute. Anyway, yeah, no worries. Anyway, interesting broadcast, but no worries. Did you flash a printed copy of the Southern Astronomer magazine there, by the way? You can come back to me in a minute about that, maybe. I signed that up, but I thought it was just email only or electronic only. Look, I was fascinated by sort of bringing the teaspoon of a neutron star to Earth and suddenly getting, instant Mount Everest, not to mention a few other problems. It's a rather bizarre
It is, yeah.
thought, but it does bring home just how dense a neutron star is, isn't it? So I was also intrigued about the possibility we may be living in caves on the moon. That's sort of going back a bit, isn't it? We haven't lived in caves for a while, but I suppose they'd be high-tech caves.
Yeah, high-tech.
And I'd like to see Pluto reinstated too. All right, thanks very much, Clint. VK3EKH, VK3SPX.
Yeah, no worries, Steve. I agree totally. I think it was a shame that they even thought about making Pluto a dwarf. I mean, now that New Horizons has been out there and has now made Pluto, it's now a planet. As far as I'm concerned, it's a planet, and those images that have come back from New Horizons when it visited Pluto, it's put Pluto on the map. We now know what it looks like. Where was the image that I did have here of that? There it is. This is Pluto, this magnificent body that's our ninth planet orbiting in our solar system. And if anybody's got a decent telescope, they won't be able to resolve the disk of the planet, but you'll be able to see its passage through the sky if you do some special photography, which is something I'm looking forward to doing. But there it is. New Horizons has now made Pluto a place, and it deserves its appropriate designation returned. So I'm totally all for that, and I suspect that the people behind this revised article that they're working on is pretty much wanting to do this too. What was the other thing? Oh yeah, I did. Now I'm not sure exactly what you were after with the Southern Astronomer magazine. I did run it up. I did show it up on the screen, which I did just a moment ago. So I think you're still on Discord there. If I have a quick look, let me see. Yeah, you're still there. Yep. Okay. Anyway, so what have I got screening there? What's this? Oh, that's something else. Okay. I see. You've published a northern limit of aurora visibility. Oh, I see what you've done. Oh, that's interesting. Okay. Thanks for that, Steve. Cool. No worries. Yeah. So I've got up on the screen right now the front cover of the magazine. As far as I know, that's what it's looking like. And at this stage, I haven't. I don't think I've got around to organising the subscription to it yet. So, but the intention is definitely to do that, so that I can, so we can read the various articles that come forth in it. So it'd be really interesting to see how it transpires over the next 12 months or so. All right. I think that's... Yeah, I understand. Normally Graham is there, isn't he? He's one of the first to call in, but I suspect he's working tonight, and he's probably involved with one of his customers. So. Okay, across to you there, Dallas. VK5 Whiskey Alpha. You're a good signal when you called in. VK3EKH.
Okay, Clint. Received very well. Talk tonight was quite good. Interesting topics and good. All right. Thanks again there. Oh yeah, the YouTube. I watched that. I couldn't get the audio on Discord. Never know what to do there. But the YouTube worked well tonight. So you must have fibre, or maybe you are using a phone. Good. Cheers, Ben, and others heard well too. Okay.
Yeah, no worries, Dallas, and I'm just checking that my audio aspect on Discord. It should have been working. So when I speak, there's a little green line that goes around the video image, and that comes up when I talk. So there should be plenty of audio there. I don't see any reason why there wouldn't be any audio, unless you had the audio muted. That might have been the case. You might have had the audio muted at your end, but I've definitely got audio happening there from what I can see. And it's good that the YouTube indicator here is flashing, telling me that it's struggling to get the bandwidth, but so far it seems to be okay. It's not struggling at all, which is good. All right, thanks, Dallas. You're about 5 to picking 10 over 9, so not a bad signal coming into Melbourne tonight. Now, was there another station there? This is VK3EKH listening. No, was there another VK5 station there?
There was, I think, Clint, but not anymore.
Well, there you go. All right, well, general call then. Is any other stations wishing to check in? VK3EKH listening. It's so quiet. Okay. All right, no worries. Well, thanks, ladies and gentlemen, for listening tonight. I'm sure there was an audience out there. In fact, I haven't checked my email. Let me just check my emails. In fact, I haven't got it open. Where's my mail? There it is. So I shall just check the email. It's opening. And looking under EKH. And I can see there's an email from you there, Steve. Good signal on 80. One from Andrew. G'day, Andrew. VK3KIS. I heard your CW experiments earlier before too, Mr. Andrew. And then again, Steve. Yes, you've sent twice. Oh, no YouTube. You're saying no YouTube? So you've sent the email twice. Then is that last week? No, Friday. It's the 7th. Oh no, I'm looking at last Friday. Okay. So there's only one email so far. My God. All right. This inbox. Anyway, yeah. So only one email tonight, and that's from you there, Steve. 30 over. YouTube okay. Cool. No worries. Excellent stuff. All right. We'll leave it at that. It's been a very quiet night. Even the Discord chat room. Let's have another look at that. Daz is there, our resident shortwave listener. G'day, Daz. Great signal into Brisbane, but the quietest speech parts fade right down. I'll speak even quietly now, so you can't even hear me. And Kim, VK5 FUSE, is there. He says, tea, coffee and biscuits. How could possibly go wrong with a nice treat? Thanks, Kim. Luke, VK3 LCG, is there. G'day, Luke. And Mike was there, VK3XL. And Stuart, VK3 UAO. And I think that's about all I can see in the chat room. So thanks very much, guys, for coming up on the chat room and listening in on the side there. And all you blokes should be able to see my video stream. There's no reason why you should not be able to see the Discord video stream that I'm running there as well, apart from YouTube. So that's fine. Okay, if that's all tonight, I shall conclude transmissions for tonight. Thanks everybody for listening, watching, and on the TV repeater, which is still coming through loud and clear. What else? There was something there too. No, I think that's about all. Where the 31st of August is the 8th. Oh no, actually, we'll still be here. The 31st of August, which I think is a Saturday. Let me just check the calendar. 31st Saturday, yeah, okay. So the 31st of August is the ATV QSO party. This is not going to interfere with the Friday night broadcast. Normally it does. Normally the ATV QSO party occurs on a Friday and the Saturday where we cross to America. But this year we're doing it all on the one day. So all the activity for the ATV QSO party is occurring from Saturday morning through to Saturday evening, and I'll just remind people of that as we get closer to it, so you can watch the activity, because it'll be all streamed on YouTube and Discord. There's actually going to be crosses to our friends, ATV friends in England. And we're going to be going via the geostationary satellite, the Q100. I think that's what it is, Q100 geostationary satellite. There'll be ATV transmissions through that as well, courtesy of the internet. So it's going to be a really interesting session. Let's hope that we will get our audio levels correct, because it's always the audio that stuffs us up. Anyway, that's coming up on the 31st of August. It's over a month away. Just thought I'd give it a plug. But I will be broadcasting as usual on that Friday night on the 29th of August. So no interruptions there. You've been listening to VK3EKH, the official station of the Astronomical Society of Victoria. On behalf of the Astronomical Society of Victoria, transmitting since 1988, concluding the session for tonight. Thank you for watching, listening. Have a lovely, safe weekend. Stay warm, and we'll be back next Friday to do it all again. So we say cheers for now. VK3CSJ on the microphone. That's Craig, I think. VK3KG, go ahead. And yeah, no worries, Craig. VK3KG, VK3EKH returning very good. Thanks for coming up, Craig. Good to hear you. You're 5 and 9. Not a very strong signal, but readability is okay. I'm getting you through. And if you go back as soon as I drop off YouTube, you'll be able to catch up with tonight. You can fast forward all the boring bits, but you can catch up with the session tonight on YouTube, because that records it, and your audio is being recorded as well. So I've got a direct patch from the audio output from the radio via the mixer to the system, so you'll be able to hear how you sound as well. Just thought I'd mention that. Good luck with the barbecue tomorrow. I hope it's undercover. This is going to be a bit of a wet weekend. There's already a fairly decent some decent rain along the coast happening at the moment, which I can just quickly cut to. There it is for those watching Vision. It's slowly making its way across the coast into into central Victoria. So yeah, it's going to be a nasty. There's a lot of cold air behind that cold front that's coming up right now. A lot of cold air coming up from Antarctica, so it's going to be nasty cold weekend. Oh, I'm actually looking forward to the warmer weather. All right, thanks, Craig. Good on you, mate. Excellent. Glad to hear. All right, if there's nobody else, this is VK3 EKH concluding for tonight. Cheers, everyone. All right, thanks, ladies and gentlemen, for watching tonight. And we'll conclude our visions, and we shall cut to the view from the International Space Station, which I'll run for a few hours. And we'll see you all next week. So I'll keep the Discord channel running as long as I desire. I have no problems with that. And so if you see the clock reading the time at the bottom there, it'll like that. It'll give you an indication that it's all live and being streamed in real time. So cheers, everyone. Take care, and we'll be Sunday morning is the WI broadcast. Look out for the WI broadcast on 160 metres on 1825 kilohertz at 9 o'clock in the morning. And then at 10:30 on the Melbourne television repeater, that one. So thank you for watching. Across to our International Space Station now. This is VK3 CSJ on VK3 RTV and elsewhere.